Okay, show of hands. Before I dive into this, who here has used Docker before? In production? Yeah, and for the recording, there aren't a whole lot of hands left stuck in the air. And the people whose hands are in the air look very sad. So I originally gave this talk 2 days ago at SaltConf. And as much fun as the vendor conferences are, and we definitely appreciate their support of the open source community, that's not really what these talks and what community is about. The real heart and soul of open source is the community-driven conferences. So I viewed that as a dress rehearsal for today. I iron my bugs out there, and hopefully things will wind up working smoothly going forward. So my name is Quinn. I spoke here for the first time last year about how to find a job, and that was successful enough that people started talking to me about this at other conferences, and they invited me back. So here I am. You're stuck with me for the next 45 minutes or so. I have a history in the open source community. I was volunteer staff for the Freenode IRC network for a number of years. I was one of the early developers behind SaltStack, and I complain about things on the internet almost constantly. I'm a crusty old sysadmin. It's what we do. So, without further ado, let's get started. You've all heard about Docker, because the first rule of Docker is never shut the hell up about Docker. It's like the inverse Fight Club model. So, I'm sorry to disappoint you all, but I'm not going to talk about Docker today. This talk is now called That Time My Boss Destroyed a Cubicle. And this is a completely true story. It takes us back in time almost 10 years to when I was just starting out as a systems administrator in a Linux environment. My new boss had just started a week before, and things were going reasonably well. He was doing everything right that you'd expect someone in a new job to do, showing up on time. He was dressing well, which, respect. He was getting in shape, and he was hoping to make a very strong first impression. Given what the title of this talk is, you can safely assume that he did. And one morning, the strangest noise just sort of echoed throughout the cubicle farm. Shuka, 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 poof! Which is not the typical noise you hear in an office environment. So we all prairie dog over the side of our cubicles. And what we see is, well, let's back up. In order to properly describe what we saw, you have to understand what caused the noise. Now, to hit his fitness goals, my boss was consuming a lot of protein shakes. This is, incidentally, a very poor idea. If you change your body composition, your suits don't fit right. Never do it. But protein shakes is what he was doing, so all right. And to stay alert, he was also drinking a lot of coffee. Now, like a good ops manager, he figured he might be able to consolidate these things. So, inside of a Tupperware container, he wound up taking some Slim Fast powder and mixing it with coffee. Now, here's a little known fact. If you remember absolutely nothing else from this talk today, this is it. If you mix Slim Fast powder with coffee, it generates pressure. A lot of pressure. Enough pressure to blow the lid off of a Tupperware container. So, yeah, that pretty much catches us up to where I was in the story. So, we peer over the cubicle wall, and we see a disaster the likes of which has not been seen since. All over his clothes, all over his desk, all over his computer, and, of course, all over himself. And he stands there with the most forlorn, shocked, dismayed, and embarrassed expression on his face that you can possibly imagine. And a year later, when I left that job, the chocolate blast ring was still there in the cubicle. So what's the point of this story? I mean, how is this is a fun tale, but how is it really relevant to anything? I mean, it's really just a story about a guy who, despite knowing how his container worked, didn't understand how it would work in production or what the failure cases would manifest as. And there's the metaphor. We're back to the Docker talk. Okay. The point of this talk is not to shoot down a promising new technology, It's to discuss some of the challenges that you're going to see when you take this promising technology and put it into production. As a disclaimer, where I work at Future Advisor, I head up the DevOps group, and we are launching our first Docker-based microservice in the next few weeks. I mean, I've used Docker in demos before myself. This talk doesn't have any demos because I couldn't find a Tupperware container. So, why is Docker in production a problem? Before we get into that, let's talk about what Docker is. Docker is a relatively new container technology that Fortune 100 companies are going nuts over, like 19-year-old college students on spring break. Why? Great question. I'm really glad I asked it. It's because Docker is not only the best container technology out there, it is also the first operating system level container system. This has never been done before. Well, I guess LXC does count. It's been in the Linux kernel for over a decade, but Docker leverages it. So, okay. And I guess if you're going to count LXC, Solaris zones have been in about as long, and Docker doesn't leverage that. But a new version of Docker came out either last week or 20 minutes ago or however long it's been, and maybe it does now. It's hard to tell. They change a lot of things from release to release, like their API. I'm sure that's not going to be a problem. But, yeah, if it's in the latest release, I haven't seen it yet. And FreeBSD jails, who a few people have been very passionate about at this conference, also count as a form of operating system level containerization. And if jails counts, I guess cheroots or change roots are going to have to count too, and those have been around since 1982. And if cheroots count, OpenVZ is effectively a cheroot on steroids, same with their paid offering called Virtuoso. And that probably counts too. And way back in the midst of time, we had logical partitions on mainframes. LPARs are also another form of the same exact concept. And if we're going to go down that far, technically, isn't a VM itself a container in its own right? For anyone who wasn't in tech about 10 years ago or so, before we had DockerDockerDocker, there was cloud, and before that, there was vert, proving that hype evangelists are not new creatures that have just suddenly come out of nowhere. They've been around the whole time. They just change forms. Which brings us to Vagrant, which of everything on this list is probably closest to Docker from a user perspective. I'm going to write some code and see it running in as short a time as possible. They call it the mean time to dopamine. They're trying to reduce that as quickly as possible, and Vagrant does a great job. So, okay, I think we sort of have to concede the point that Docker is not the first ever operating system level containering system. So if it's not the first, what explains all the hype around it? Now, I'm sure that the $180 million that these 10 investors have put into Docker itself, that's not ecosystem companies, that is Docker corporate. Over 4 funding rounds, Docker, a company that is still struggling to articulate a business model, had absolutely nothing whatsoever to do with the level of hype that, in fact, you see Docker everywhere. That would be ridiculous. This is a technical conference, though. We're not going to get into the business reasons behind Docker. So let's talk technology. Does anyone remember a 3-tiered architecture? Now, this is something that you'd see back in the dark ages of computing, also known as 3 years ago. And it's a little bit different. You have different tiers of systems. You have your web servers, you have your application servers, and you have database servers. Generally, you have your application running on the app server, generally in Tomcat or something like that. Your data lives in either MySQL or Oracle or, God forbid, Postgres, depending upon your personal choices. And things were segregated out, and you knew where things were. Oh, the app tier is running a little slowly. I know where that is. I'm going to go check it out and see what's going on. And now with Docker, we're undergoing a tectonic shift away from that into a microservices-based architectural model in a lot of cases, where things wind up living wherever they wind up getting scheduled, and there's no real guarantee that where a service is right now is where it's going to be in a few minutes. So I'm going to stop here and talk for a minute about what a microservice is. A lot of people nod really sagely when the term gets used, but don't actually know what it means, like me a week ago when I was building this talk. So let's get into a little bit about what this is. But as a disclaimer, going with a microservices-based architecture is not going to save you from yourself, but there's a very good chance it'll let you kick the can down the road a few years until the next architecture comes along to save you from your own poor decisions. It can buy you some time. So, given that there isn't really a clear universal definition of microservices, they do have some defining characteristics, which is what I want to focus on. And yes, I know this is not an exhaustive list. Everyone has their own slightly different take on this. These are the ones that I found consensus around. For starters, instead of having one giant monolithic code repo that runs your entire application soup to nuts, the idea is that you have each function gets broken off into its own process. So each one of these microservices does only one thing. This harkens back in a lot of ways to the old Unix-style model of do one thing well, and then you can chain different things together to get different results. And generally speaking, as an accepted characteristic these days, you wind up with communication points between these microservices, taking the form of stabilized and versioned, please, APIs. So the idea being then that you can wind up having communication taking place in a standardized way. And that winds up lending itself to a very modular style system design. So let's pretend for a second that you run a store of some kind that sells physical goods. I know, crazy concept, but let's pretend. So if you have a microservice, its job might be that all it does is it takes a request for a given product ID that you have, and it returns the number of those units in stock. That would be all that it does. Now, how it does that can change completely from version to version, as long as it continues to meet the requirements of everything else in the system around it. So I can change the database over from MySQL to Oracle. That's written in Python today. I'm going to rewrite the entire thing in Scala, because that's what the cool kids use. But as long as the API itself doesn't change, nothing else in my environment, and thus nothing else in the entire world, has to care about what my microservice is doing under the hood. And I can launch a new version, fail back to the old one, and as long as they're compatible and returning accurate information, life goes on. That's the promise. This also means that, from this perspective, you wind up in a world where this becomes extremely agnostic, in the sense of it just sees your servers as resources at this point. CPU, RAM, disk, and they can cohabitate completely different containers that are doing completely different things on the same system, as long as resources are available. You know, kind of like the promise of virtualization said 10 years ago and change. And one of the great bonuses of this that speaks directly to the needs of businesses who are pursuing things like this is you can break up your ever larger engineering teams into smaller groups, focusing on individual components about this. So you now have a small group of developers that only works on one thing, rather than 500 developers all working on the monolith, which leads to a different problem. A group of whales is called a pod, a group of crows is called a murder, and a group of developers is called a merge conflict. That becomes a little bit of a challenge as you continue to scale. Now, those are the characteristics that I found that people agreed on. There were some that were in contention. I ran into someone a few days ago who swore that it couldn't be a microservice if it contained more than 100 lines of code. Okay, I see why you might think that. You're wrong, but I can see why you would think that. It doesn't matter under the hood how big or small it is, as long as it adheres to recipes. It does one thing well, that's it. Okay, lastly, your whiteboard diagram winds up looking a little bit like this, which, when you've got an audience, is much more impressive than a three-tier architecture diagram. It's complex, and it's interesting, and unfortunately for everyone who has to maintain it, it goes deeper. See, strapping this stuff into your servers as they are right now today doesn't quite work. It's expected that a lot of these systems have the ability to call out and control things about their environment via API calls. Most of our server environments don't have this. So you run it underneath something that provides that, such as AWS if your company runs on money, or something like OpenStack if you're here on the grounds of reason. This is an official OpenStack architecture diagram. This is why you'll see me in the bar for the rest of the conference. I'm kidding. After this presentation, there's no way they're going to let me stay. So now you've got a layer of unclear complexity riding on top of another layer of unclear complexity, all in the name of chasing after a modern systems architecture. And that's sad. Weep for the state of DevOps, and weep for the sad puppy with coffee and Slim Fast stuck in his fur semi-permanently. But how did we get to this point? How did we get to where we are from where we started? The promise of Docker is compelling. It makes dev look just like production. And that's great, because it solves the historical problems we've seen of development and operations being two different silos that don't really communicate except by throwing things over the wall of confusion. And this is old school, before DevOps came along. We're all DevOps here, right? It's totally a real job title. But yeah. The Docker talks about this in the context of the container ship analogy. When you're trying to ship something long distances, whether it's electronics or foodstuffs or small animals, you can stuff them all into shipping containers and then hand it off to a shipping provider. And they don't care what's inside the container. They just care on getting the container by land, by sea, by rail, whatever it takes. And that's the similar divide that Docker envisions wind up solving. And it's great. It makes development on your laptop look identical to the environment in production. And they're right to an extent. The container looks the same in both places. It just works. And this solves very neatly the "it just works on my machine, your production environment must be broken" argument. Except, you don't have to schedule containers on your laptop. They're just on your laptop. So Kubernetes or Mesos or whatever you use to handle container scheduling is really, really heavy, and it's really, really complex. And they're the next frontier in this space because no one really understands them or really gets how they work. On a related note, if you work on Kubernetes or Mesos, please call some of these gullible, respected investors immediately. I'd like 10% of whatever you get. You're welcome. Okay, no more business talk. This brings us to our next challenge in implementing containers into production, which is networking. You don't see a whole lot of people talking about what networking looks like under Docker in the same way that you generally don't see a whole lot of people talking about what happens in a slaughterhouse kill floor. It's not pretty, and it doesn't work particularly well, and we're working on it, is the official state of these things. It's still complex, it's still slow, it's still arcane, and networking still just works in my laptop Docker environment. So let's make it worse. In most traditional environments, there are ways of doing upgrades and deployments that companies have all figured out. The idea is that you phase some things in and out. You have a new version coming out. You're going to go ahead and roll that new version into one of your 10 web servers, put that one web server in there to get some element of traffic, and you're going to instrument the piss out of it. And that's great. It's called canary analysis, where you have that, and if things don't look right, or the error rate counts on that, you can take it back out and investigate further. It's a very low-impact way of doing deploys. Now, this works relatively well. There are times where it breaks. For example, if you're doing a schema change on the database, you then need to come up with some way of making sure that you have a viable rollback, that both the new version and the old version of the code can still talk to the database, regardless of which state it's in. And we've solved a lot of this stuff, but these are complex things that we've done to get these things solved. And your old release process, these complex monstrosities you've built specific to your environment to solve this problem, once you move to Docker, that whole thing becomes obsolete. You get to reinvent again what it looks like to handle the rolling deployment problem. And again, none of this is a concern on your laptop. I'm just going to stop it, run the schema migration, start a new version, life goes on. But if you're in production, your problems are just beginning. So now we're into the heart of this. Has anyone here ever modeled a truly immutable infrastructure and lived to tell about it? Okay, I see half of a hand out of a room of about 100 people. That's about right. Instrumenting anything in an immutable environment is fun. Let's say that a system, or a container in this case, stops working, or God forbid, it's slow, or there's an intermittent problem, something that isn't easy to point at. How do you get meaningful metrics out of a container like that in a world that by the time you get the metric, the container has already been replaced? You better hope that all the information you're getting out of this is enough for you to troubleshoot these things. And as an added bonus, traditional monitoring solutions fall down in a big way, because every time you start a new Docker host with a Docker container, its hostname is randomly generated. Imagine trying to shove something like that into Nagios. Imagine happy hour tonight at the bar. It's going to be packed. And that does break things. So, tied closely into the monitoring approach, we also have the concept known as supervision. And process and container supervision becomes a very tricky thing. And because sometimes processes die. And there's tooling in our environments to ensure that they either A, don't do that, or B, if they do, they're brought up again safely and sanely. Docker does try to do this, but so does Systemd, and Supervisor D is another way of approaching the same problem. And there are 3 other tooling sets that do this too. And something I'm just going to touch on now, that we get into in future slides, is by this point on the decision tree, as you solve for each one of these, you're rapidly approaching a point where there are enough choices at each layer that you are no longer doing anything approaching what is similar to what other shops have done. You're slowly becoming a unicorn here. Oh, and again, none of this is in your developer environment, because the developer environment took 30 minutes to set up, and they're just churning containers out like it's a factory. Okay. So, now we're talking about configuration management, or config changes. Docker is increasingly seeing themselves as a configuration management solution. They are wrong. I've spent most of my career working in the configuration management space. There is a lot of edge cases they don't address. For example, let's say that you're not completely crazy and there's another environment somewhere between a developer laptop and your production environment. Let's call it staging, for the sake of argument here. When a container, ideally the identical container, comes up in a staging environment versus a production environment, where's its database endpoint supposed to live? What does it talk to? How does it know what environment it's in? There are a number of these things that you don't bake into a container, and there's a few different approaches that people take. Some people like running a configuration management agent, such as Chef or Puppet, inside of a container, primarily because they like to watch the world burn. And while there are arguments to talk about running other processes inside of a container that might wind up doing communication on the back end, or even something on the host itself that winds up orchestrating this, which is often a better model, that's not a consensus decision yet. People haven't crossed that yet. Additionally, if you are running a configuration management system, a traditional one, call it Salt, Ansible, Chef, Puppet, CF Engine if you lost a bet, registering and then deregistering an ephemeral piece of an environment that is not going to be around long or is long-lived is far from trivial in anything approaching a secure fashion. And, again, what are you doing? They're immutable containers. That's what they call them, immutable infrastructure. It's in the name that these things don't change. So if you're going down that road, you're really not having a great time with this. The idea is not to change it. It's to throw it away and replace it again with something new and better and configured the way you want it. Be careful, though. You still have that whole rolling deployment thing to think about. A better answer than configuration management for some of this is the idea of service discovery. Containers need to be able to find each other. They need to figure out where the master database is. They need to know what load balancers to register themselves with. And you need to do this securely, because a lot of things you give a container are things not just like, which database am I talking to? What are the credentials to talk to that database? And that's something that's challenging. Passing environment variables into it through the Docker environment isn't really a great plan, but it works. there are a lot of key value storage systems that wind up trying to address this, and people have used them in different ways. Consul, Zookeeper, etcd, Redis, MongoDB. That time I abused my SQL so badly, I'm still not allowed within 500 feet of an actual relational database. DoozerD, Sensu, Eureka, Pillar, DNS, and the list goes on. And none of these things are straightforward. All of these things have failure modes that are hard. And approximately none of these considerations generally arise your first time out with Docker in a development environment. Let's keep climbing Mount Hopeless here. Okay, so you've built an awesome container. Now, where are you as a developer going to put it so that I, as an operations person, can safely put it into production? Now, this is a bit of an interesting one. As a part of their business model, the last time I looked, though it's changed, Docker offers private registries and private hubs that you can wind up storing your proprietary container on that no one else has access to. Their pricing ranged, at the time I looked at this, from $150 a month for a starter package to, how about you acquire us, please? So it has price points to suit all tastes, and that's great. And it was a very reasonable model. And it made and the challenge that it came out here was that not too long into that, Amazon came out with the Elastic Container Service, where you can store your containers with Amazon for the princely sum of 10 cents a gigabyte a month. Unless you're doing something psychotic, like shipping around petabyte-sized containers, P.S., never do that, it's not going to blow out your budget no matter how far you scale. It makes Docker cheap as free. And unlike virtually anything else in the talk, I don't have a problem with that. But these folks might. Docker is still working out what their business model is, because that seemed to be a bit of a non-starter. And this is still not a business plan talk, so let's go back to technology. So we're almost out of room on the slide here. So hopefully it means I'm almost done. If another group or another company hands me a container, it's very, very hard for me to go ahead and audit that container. How was it built? What's inside of the container? Is it sane? And even past that, if I grab a MongoDB container from the Docker Hub to run Mongo, do I agree with the decisions that were made as far as how that container and service are set up? Does the way that it was set up make sense in my environment for my use case? And that's not a matter of right or wrong. That's a question of, does this map to the way that we have designed our systems? And I've seen a lot of talks over the last 6 months on the proper way to build containers. And there's been one emerging theme that every single one of these talks has hit on, which is that all of the other talks are doing it wrong. We are far from consensus. All I have to go on when I get handed that container is that my developer says, shut up, it's fine. So we're back into the very unfortunate situation of, I've just been handed something that I'm running in production now. I'm not really sure what's inside of it, and at 3 in the morning it's going to break and wake me up tomorrow. There's a certain failure of the trust model in this kind of handoff here. Not necessarily a strict Docker problem, but it does tie into the larger challenge we're talking about here. And all of this ties into security, which finally completes this giant list. And I put that security for last, because that's generally just something you could bolt on after the fact. You don't need to build it in. Yeah, you folks laugh. When I made that joke at RSA, nobody laughed. So let's pretend for a second that a new OpenSSL vulnerability comes out tomorrow. Right? I'm shocked, sir. Shocked. Yes. And third-party containers are everywhere in your environment. Which ones of those containers were patched? How do you find out? How do you patch them? Recently, it was reported that a majority of Docker containers living on the public Docker Hub are still vulnerable to Heartbleed. And I believe it. I built a Docker container that I know is, because I built the container months and months and months ago for a demo, and that's all I've ever used it for. And I should never, ever approach a production infrastructure It runs locally on a projector. I make things happen. Everyone claps, oohs and ahs, and praises me, which is really why I'm here. And life goes on. There's no need for me to patch these things. So there you have it. A giant list of things that apply in production that don't apply at all in development. And by the time that you've solved each and every one of these, I can effectively guarantee you that you have made decisions that no one is going to have made the exact same way. Which means that when something does go wrong, and let's face it, we're talking about computers here, something is going to go wrong, you don't have the same sense of community and the same sense of support that you do for other stacks, because you've built an incomprehensible unicorn.
Unicorns are worth a lot of money.
You'd think that. What happens when it breaks? What happens when it's slow? And this also opens it up to a giant myth that I want to speak to. And because this type of thing is the exact sort of thing that was done to create giant architectures at stupendous scale. Google, Facebook, Netflix, Twitter, they've all had to deal with this. And they've all gone down similar paths, and they all have their own unique infrastructures that they have to address these things. And we believe, almost instinctively, that these shops know the one true way to solve all of these problems on how to scale an infrastructure. And they don't. They solve their own problems. And their problems look a lot different than most of our problems. For example, Facebook has over 1 billion users, active users. Most of us can't make that claim. Twitter has how many messages a second going through? And Netflix is sort of a great example of this because they built all of their own AWS tooling. What people like to forget is that at the time that they did this, Amazon's tooling itself was not up to where it needed to be for them. So they had no choice but to build their own given the speed of growth they were undergoing. It's now many years later. The tooling has caught up. You don't need to roll your own tools locally to solve global problems in most shops. And here at the end is when we get to why Docker is relevant to me, a specialist in configuration management. The idea of pure immutable infrastructure and a configuration-managed environment are not binaries, yes or no. They are at opposite ends of a very broad spectrum. Virtually nobody is entirely on one end of this or the other. Is the world trending more toward immutable? Sure. And that's fine. It's not a pure thing, though. It doesn't mean that configuration management is dying. Not by half. After everything that we've shown about the challenges you're going to face in running an application in an environment, does anyone believe that this is anything resembling just a quick migration? These are serious problems, and existing applications need to be torn apart and rebuilt in order to lend themselves into this kind of a model. Take something relatively straightforward and simple, like RabbitMQ. Let's say that I want to run RabbitMQ in a Docker container. Reasonable ask. I go ahead, I start up a Docker container, mounting a data volume where all of the data lives. I start storing things in the queue. So far, so good. I stop the container. I instantiate a container again, mounting the same volume, and my data is gone. Why? Because the way that RabbitMQ stores things under the hood is entirely hostname dependent. And because Docker hostnames are randomly generated, it doesn't see its own data. Now, is this solvable? Sure. But that's one example of a very small component of a much larger infrastructure. This is not a situation of picking up your legacy environment and strapping it into something else. You're going to have to modify your environment rather heavily. I'd like to give a couple thanks as well. Michael Ducey tweeted this out originally, which got me thinking, and built out most of the structure of this talk. It was Julian Dunn then wound up tweeting it out, but I didn't see the original tweet. In fact, it was pointed out to me after I gave the first version of this talk. Someone sent me a better/funnier version of this tweet, which I found far more appropriate. And I want to thank Tyler Fitch over at Chef for helping me track down the original authorship so I could attribute it appropriately. There's something weird about Chef in that all of the people I've met who work there are hugely active in the community. I think that's a fantastic direction to be living in, and they're always willing to pitch in and help. So thanks again. So this is me. Thank you all for coming. Does anyone have any questions? Yes, question in the back.
So, if this is, are you saying this is not a good way to go? Is there a better way? Do you have some insights into a better way to do this?
Sure, the question is, if this is not the way to do it, is there a better way to do it? And my answer to that is sure. I'm not saying that microservices architectures are necessarily a bad direction to go in, but I will say that by the time you've gone through every item on this list and said, that's not a problem in my environment because fill in the blank, then you've already grown past this talk to a point where you're at least aware of where the dragons are, and you have a plan to mitigate that. And by the time you can build all this infrastructure and tooling around from it, you have built a business case to move to Docker other than it's cool or it's exciting. So if you're at a point now where you're telling me that a legacy application needs to move to Docker, my immediate response is why? What is it you're hoping to gain by doing it? Because a lot of times the pain far outweighs the benefit of doing something like this. We're building out a Docker microservice, but I'm not, for example, saying that we refactor everything we've built over the past 6 years into a microservices-based architecture. That's the sort of thing that requires significant thought, planning, and to be very blunt with you, this first microservice we're building is going to hit a lot of these problems. We know they're there. We know we're going to encounter some of them. And how we solve them is either going to help us learn a lot about this entire environment, or, entirely likely, say, wow, this is terrible. Let's not do this. Let's do something else. And either one of those are valid outcomes. That's why it's a proof of concept, and not our whole stack is moving by February, which is a scary thing to say. Yes?
Were a lot of these arguments trotted out for the migration to Virgin Cloud as well?
They were. The question is, for the people listening to this in the far future, hi, Mom, is that weren't these same arguments trotted out against Verge and against Cloud? And the answer is yes, absolutely. Because in the early days of the cloud environments and of virtualization technologies, the management tools were not there. But there were still these evangelists saying, do it and do it now, don't look back, you won't regret it. I work for a finance company. I don't have the luxury of treating production as my personal playground for a lot of these architectural events. Is there going to come a time where this becomes a lot more streamlined and simple? Possibly yes, at which point this becomes a very different conversation. I truly hope that in 1 or 2 years, this entire talk is irrelevant, moot, and sounds like I'm shaking my fist saying that cars are way too dangerous, let's go back to horses and buggies. But at this point of the cycle, I don't think the time is on us yet, regardless of what the hype says.
And as a follow-up question,
Sure.
Sorry.
No, please.
Did the legacy applications ever get moved to the Virch or Cloud hosts?
The question is, did the legacy applications ever get moved to Cloud or Vert? Yes, many of them did. But by the time that happened, there were tools specifically built to do that. Right now, no one is going to there's no tool that I'm aware of that will let me pick up a Ruby on Rails app in its entirety, built as a monolith, and drop it into a microservices-based environment. I mean, theoretically, you could start using Docker containers as a form of virtualization and use them as just giant fat VMs. But that's when developers pass you a 2 gigabyte container and you say, so what's this? Oh, it contains a full copy of the entire database. Okay, so when I stop it in a week and then start a new copy, what's going to happen? Oh, don't do that. We'll lose data. Let's talk about what Docker is again. And that's really what this comes down to, is what is the problem you are attempting to solve. Most people haven't been able to articulate that when pressed. I spent some time as a consultant moving in this direction, and those questions do come up. Yes?
Somebody who's still struggling with why you would use Docker,
Mm-hmm.
use some virtualization stuff. But could the same argument be also potentially used against snap packages?
Against, I'm sorry?
Snappy packages.
Snappy package, I'm not familiar.
Ubuntu's new sort of containerized packaging.
Okay, almost like a rebranded Docker style thing. Instead of going out and installing a giant apt package, you go ahead and install a snappy package.
Yes.
Okay. The question then is, how does something like this compare to something where in Ubuntu you can wind up and get an entire service installed, up and running, configured sanely through Snappy? Was it?
Yeah.
Okay.
But they're actually talking about potentially going away with
Mm-hmm.
with
Yes. I haven't heard of this yet, and I'm running in the Ubuntu shop, so that means I'm either behind the times, which is entirely possible, or it hasn't had penetration yet to a point where it's risen to my level of notice. Off the top of my head, some challenges that you could very easily see in that comes down to what if you disagree with some of the architectural decisions and the setup decisions that are made. Do you need or want that level of granular control? Increasingly, the answer is going to be no. And the defaults work for more and more people as things get expanded. And is this potentially something that come 2018, I think, when the next long-term LTS gets released and that starts going into a number of server environments, is that something people might start adopting? Possibly. That said, one challenge with it is that companies are increasingly looking to shy away from things that are specific to one vendor, be it Red Hat, Canonical, or any of the or SUSE, who has a great presence here. Specifically because in a world where configuration management over the past decade has taught us is you don't need to know the ins and outs of your specific operating system. Just make sure this package is installed. And the intricacies of a Debian versus a Red Hat system effectively become abstracted away. Will we see something similar in this sense? Maybe. I think it's too soon to say, but I think it's a good question. Yes?
Yeah, I work for Red Hat on Florida, so that is kind of like their XDG app, if you've heard of that. And I think it's designed to facilitate not being tied to a vendor anymore.
Okay.
They're both answers from vendors to the problem of how can someone else build a thing that deploys on top of my operating system but can't screw with it. It's almost like the App Store model of this is like your app space and we own the system space and you can now build a snappy thing that goes in the app space and does stuff.
Gotcha. Yeah, and there was also some drama on Twitter recently. That was just a little bit more expounding on Snappy. Rather than repeating it, anyone listening to this can go ahead and look it up online. But that'll probably give a better answer than I will be able to summarize as. But there was a recent kerfuffle on Twitter about a day or so ago where Solomon Hykes, the technical co-founder of Docker, was involved about some upstream package was looking at rolling it out but not calling it Docker, similar to the way that you had Firefox versus Iceweasel due to a number of other constraints. So we're starting to see upstream deviating significantly from what gets released into distribution packages. So I think this is this area from a business perspective is sort of a giant question mark right now. And the early adopters are wrestling with these things, and past a certain point, I think there's going to be some consensus hammered out, at which point this talk evolves dramatically. But that's not today. Yes?
We're starting from scratch.
Mm-hmm.
We have the opportunity to design a proper architecture.
Mm-hmm.
Would you go with containers or traditional VM big management?
Okay, the question is, if I were starting today for a greenfield project, would I wind up going with containers or would I wind up going with a more traditional systems architecture? And my answer to that would have to depend upon what it is I'm building. Is it something that absolutely, positively has to be rock-solid reliable? If so, something that's undergoing dramatic development at a very brisk pace is probably not a great fit for that. If it's something that, for example, no one on God's green earth would ever care about, like Twitter for pets or something, then there's not a whole lot to be lost by, okay, we've taken a small production outage and a few of the barks didn't wind up going out, but that's okay. It'll catch up in the aggregate. So if you're running a hospital or a 911 call center, I would strongly suggest not going with the latest shiny. But it really depends on your risk model and your risk tolerance. The argument that I've always heard is when you're at a company, you get more or less 3 innovation points, however you want to break those down. What do you want to spend those innovation points on? For me, the answer has never been the infrastructure, unless it's an infrastructure company. I tend to hew toward the conservative. I'd rather do something innovative with the application itself, rather than wrangling with how that application comes to be. Any other questions? Oh, one more in the back? Yes. Tectonics?
Yeah, more or less.
Okay, I have not looked at, is that their effective, Docker Compose equivalent, or?
No, it's like their Kubernetes. It solves all the production problems for you at the cost of $5,000 per machine per month.
Okay, apparently a vendor has the secret sauce of $5,000 per machine per month through CoreOS. I've not heard of it yet. Again, I work at a finance company, and that's too rich for even my blood. So there's probably some work to be done there. I will counter with the fact that every challenge that I've put out there is to some extent a conceptual challenge, not just in what you do, what buttons and knobs you push, but how you approach software architecture. And any vendor that steps into this space and offers a soup-to-nuts solution around the entire thing, regardless of price point, is still under the hood going to have to be solving all of those things. It becomes another spectrum. At most companies, on one side you have, I'm going to trust vendors to take care of it. On the other, it's, I'm not going to pay vendors anything. I'm going to hire smart people and trust that they will be able to implement and solve these things. And where you fall on that is really going to be dependent on you. But there's no magic sauce that says that a vendor will never encounter the same problems that you would. They just ideally have a larger scale, a better vantage point to fix some of them. Again, this is a space that's rapidly in motion. Okay, please make sure that you evaluate this session online. I hope you enjoyed it. Tomorrow morning, first talk of the day, I'm giving another talk called the Hangover Track. It's called Terrible Ideas of Git, where I wind up talking about terrible Git anti-patterns, and it features a live demo using Docker. Thank you.